Dear colleagues, my name is Viktor Fedoseev from Samara National Research University, and I would like to present our paper about robust watermarking for satellite images. You know that satellite images is an expensive product, and that's why the issue of copyright protection is of great importance for them. Uh, Digital watermarking is one of the most common means of copyright protection. However, it leads to distortions in satellite images. To avoid such distortions, usually uh, some reversible watermarks are used in different applications, but they are not robust to image transformations, so they are removed from the image when something goes wrong. And that's why in our research we propose another solution to use irreversible robust watermarking, but apply it in semantically insignificant areas. For example, water surfaces, cloud areas, and so on. The objective of our research is to investigate the applicability of robust watermarking methods uh, into semantically insignificant regions, or they are also called as RONI, regions of non-interest, for satellite image protection. And here some stages of our research are listed here. Our approach has two stages. The first one is RONI segmentation, which is implemented using a trained neural network model. And the second stage is watermarking into the RONI area. For this stage, we used 4 classical robust methods and one modern one. And here you can see the workflow of our transformation with satellite images. In our research, we used several architectures, which are UNet, FPN, UNet++, DeepLab v3, and SegFormer. To evaluate these models, we used 5 quality estimation scores and performed a small research on the data set provided by Kaggle. And here you can see some hyperparameters used in our investigation. So we found that SegFormer has shown the best performance, and so this model is used in further investigations. Now let me briefly describe our watermarking methods, which we tried to apply for watermarking RONI area. As you maybe know that all of these algorithms previously were applied for watermarking in the whole in the entire image, and we tried to make a modification of 5 algorithms to apply these algorithms within the part of the image. So the first algorithm is JAWS. It is based on shifting a pseudo-random template and repeating them and adding it to the image area. And that then when we try to extract this watermark, we correlate our image with the known template. Another one is a DWT-DCT algorithm. In this algorithm, we perform DWT, wavelet transformation. Then we divide the domain into 4x4 blocks and apply cosine transform and watermark and embed a watermark in mid-frequency elements. The max DCT algorithm, the third one, is a modification of the previous algorithm. It works only at LL1 subband, and in this algorithm we perform watermark embedding directly into 4x4 blocks without cosine transformation. And for watermark embedding, we use a QIM-based technique. And the fourth algorithm is DWT-DCT-SVD. It is a modification of max DWT, and here we perform DCT transformation and then SVD transformation, SVD decomposition of 4x4 blocks, and use the same embedding method based on QIM. And the last one is a modern watermark anything model. It uses three model components, which are embedder, augmenter to improve the watermark robustness, and a watermark extraction stage. In our investigations, we first analyzed the average embedding distortions after applying all five watermarking methods. And we compared the case when we performed entire image watermarking and watermarking into RONI areas. And it is clear that watermark embedding into RONI significantly improves final image quality, and moreover, all the distortions introduced by the watermark embedding are located in semantically insignificant area. And here in the table you can see the watermark capacity for all five methods. To investigate the robustness of the algorithms against various attacks, we used Waves protocol for the test dataset of 100 images, and to evaluate our watermarking quality, we used the correlation coefficient and PSNR as image distortion measure. Here you can see some results obtained for four classical algorithms in the case of RONI watermarking. Here we used the measure true positive rate at 1% false positive rate in dependence of PSNR values. And so higher values show that the method is robust against some transformations for the precise value of PSNR. And the graphs show that JAWS and DWT-DCT are the most robust against almost all the attacks except for the geometric ones. And when we compare these results with the results obtained by watermark anything model, then we see that it significantly outperforms the classical algorithms for this case. And here you can see two diagrams showing different robustness to different attacks. In the case when we embed the watermark into entire image, and when we used it for Ronnie watermarking. And you can see that WAM is much more robust against most attacks, including the geometric ones. However, it shows a lower distortion against JPEG compression. So in conclusion, we implemented various Ronnie segmentation models and adopted 4 classical watermarking algorithms and WAM for Ronnie watermarking. And we found that that segformer has the best performance across 5 metrics, and WAM exhibits a higher robustness compared to classical algorithms, especially against geometric attacks. So, thank you for your attention.